quantum technology is developing actually in two languages. The language of science is about superposition and entanglement, and the language of commerce, which is about customers and ROI. And those of you that know me know that I like understanding the meaning of things. I like studying discourse. So this is very much a translation problem, and this is why it's fascinating to me. You might also be aware that the United Nations declared this year, 2025, the International Year of Quantum Science and Technology. So it's really about time that the information systems community took on this project of trying to understand what quantum is in the scientific arena, what it is in commerce, and how those two fields come together. So I'm Sharon Miranda, that's Naif, and sorry, I'm not going to try and say you guys last names, and Chinanzo, my two talented co-authors on this project. I'm going to turn it over to Chinanzo first, and then Naif to talk us through the results.
Thank you very much for having me, and thank you to my chair. She's an amazing woman. So, here, two important voices in the field. You can see the Foray and Martinez make some points about quantum computing. They said breakthrough don't matter unless they become real systems that create real value. The Foray say physics only becomes true when it's actually applied. Martini also believes that the step after discovery is building solutions that make business sense. What quantum computing is? Classical computing, as we all know, uses zeros or one. Quantum computers use qubits, which can be in several states at once. Because of this, they can explore many possibilities at the same time. For some problems, this makes them much faster than supercomputers. For business, this could transform optimization, logistics, materials, and finance. For society, this brings benefit and risks. Faster discovery, but also potential disruption to securities and industries. While ecosystem, a technology as big as quantum computing does not grow inside one company. In information systems and management research, we don't question the idea that innovation is contained within a single firm. Innovation happens across organizations, as we all know. So we set out to understand how actors connect, share ideas, and make sense of new technologies together. We have learned a lot from the regional ecosystem and platform ecosystem like the Apple iOS. So quantum computing does not feel like this ecosystem as we know. It is more complex, more disruptive, and not tied to one place. This development is global, we see it across the globe. So our main research question becomes, how does a global innovation ecosystem form a disruptive technology like quantum computing? Especially when scientific and commercial organizations both play major roles. So that brings us to the next slide, understanding this ecosystem. To answer this, we look at on innovation ecosystem. And for that, I really think my professor and mentor here, because she really drilled this project. So this ecosystem are a group of loosely connected actors that coordinate without central authority. Organizations depend on each other to understand new technologies, actually. We know that industry-university partnerships are crucial. For example, Harvard created on commerce and licensed to 3 points. This actually speeds up the scientific progress. Now, in ecosystem, organizations contribute in numerous ways. They contribute material resources, and we can see the paper from Hannigan et al. They also contribute cultural resources. So for material resources, we see tools, technologies, infrastructures. For cultural resources, we see concepts, the language used, and shared linguistic, and shared understanding. But even with this, destructive technology are still hard to understand because transferring knowledge is never easy. Let's talk about the discourse over time. This is where the discourse becomes very powerful because press release, public statement, and the media help actors learn about this technology without investing in it directly. Discourse can help us define use cases, shaping how the technology is actually used, which we term technology in use in our research. Now, here comes the heavy lifting, the computational theory construction, and there's no other person more qualified than Professor Simon Brenda, which is renowned for this method. In our study, we use computational theory construction to understand the ecosystem emerged through discourse. We analyzed 35 years of press release on quantum computing, and it came from universities like MIT, Berkeley, UC Santa Barbara, and industry leaders like IBM, Microsoft, and Google, and startups like Dewey and IonQ. So in total, we analyzed 4,000 press releases. Our method, we use 3 main analyses. Number 1, temporal bracketing, to identify and understand the meaningful errors across the quantum computing development. We also use content analysis to understand the discourse to focus on. And we use social network analysis to see how this relationship emerged and evolved over time. The 4 areas of quantum computing. We identified 4 areas. And number 1 is the foundation of quantum computing, where we see scholars like Feynman, Shaw, and early theories of quantum computing. And area 2 is diffusion, where we see the industry play a big role. This is where IBM, Google, and Amazon enters the space. And number 3, we see the technical challenges, the scaling error, and error handling. And number 4, the cybersecurity and the risks involved in quantum computing, the concerns about motion disruption. Then, the discourse and interest over time. This slide shows the increase over time. As you can see, the red line is numbers of press release over time. The blue line, we analyze the Google search trend over time. Both of these lines shows that communication and public interest grew together in synergy. And with this, I'll call on my next colleague to present the remaining part of the research. Now, sure. Thank you.
So recall that we began the analysis of the discourse content by surfacing 4 areas of interest: cybersecurity and risk, use cases, quantum technologies,